All right, so this is the graph of 1/4 x to the negative 3 power, which is also 1 over 4x cubed. So that's where you get that division by 0 at x equals 0. And we see that here in the graph, that that's an infinite type discontinuity, and thus excluded. So C is in Charlie is the answer option here that's going to give us the appropriate domain. Notice the difference between C and D. D includes 0, so that's not right. We want to exclude 0. C is the correct answer. Questions about that one? Okay, cool. Not a power function, often missed. You guys always point these out. This is a frequently missed problem. So the question is, can I write this in the format f of x equals a times x to the n power, where a and n meet those criteria I talked about earlier? So can I rewrite this one in this format? Yes, it's already in that format. I don't have to rewrite it. This one, yeah, that's okay. That's 1 times x to the 1/2. That meets the criteria for a and n. Let's get back to this one. 2 times x to the negative 1. Yeah, that one's okay. It's a power function. It's not a polynomial or monomial, but it is a power function. The criteria was a little bit different, as you recall. But this one, how can I possibly write that in this format? X is in the exponent. Can't do it. And so that one is not a power function. I cannot write it in this way. Impossible. Often missed. Frequently missed. People think this negative is the trigger. Nope. It's something I can't algebraically manipulate to look like this. Let's solve a radical equation, shall we? Now this one's kind of funky because I got a bunch of radicals, but we'll make it happen here. Square root of x plus 4 equals the square root of x plus the square root of 2. So the first thing I want to do is isolate a radical. That's already done. I got it isolated here. So the second thing is take both sides to the power of the index. On the right side, that's going to be funky, but and remember, extraneous solutions are possible here. In other words, legitimate algebraic solutions, once you arrive at through legitimate algebraic means, that don't actually solve the equation, because we lose that generality. You remember my argument about squaring something? Destroys the sign. And so we squared both sides here, we destroyed the sign. The answers might not work, so we got to double check them. Okay, so the square root of x plus 4 squared is just x plus 4. That's easy. But over here, we'll use a little shortcut. A plus b squared, well, remember that's a squared plus 2ab plus b squared. You can FOIL this out if you like, and you get the same result. Now, one quick tip. When I have one property of roots, the nth root of a times the nth root of b is the nth root of a times b. So I could rewrite that middle term where it's under one root here. Like so. Now let's isolate the radical again. So I'm going to subtract 2 from each side. Subtract x. And I get 2 equals 2 times the square root of 2x. Divide away the 2. Square both sides again. 1 squared is 1. Square root of 2x squared is 2x. Divide by 2. X equals 1/2. So is that a legitimate solution though? I don't know. Say again? Indeed, yes. So let's just see if it all works out. So I got the square root of 4.5, 1/2 plus 4 is that, and then the square root of 0.5 plus the square root of 2. If this is right, this will be the same Yes, that is a legitimate solution. See how these decimal values match. That's one way to check it. There's another way I'll show you, and it's one I would highly recommend that you commit to memory. So I can test any equation this way, any equation. Doesn't matter if it's anything from algebra 1 to calculus, you can test it this way. So I'm going to put the left side of the equation in for y1 and the right side of the equation in for y2. Graph. And we're looking for places of intersection. We're zoomed out kind of, so it's hard to see. But we know it's somewhere around in our second trace intersect option, 5. First curve, second curve, guess. The closer you guess, the quicker it'll collapse to it. But in general, you don't have to worry about getting too close. X equals 1/2. So you see how it gives me the legitimate solution only. This technique will never give you an extraneous solution. It will only ever give you the exact right solution. Questions about this? Okay, cool. End behavior. So all we need to know for the end behavior is this. Make sure that mic's picking me up okay. This first term, that is the highest term. It's in standard form. So that's the first A value is positive and the N is odd, which means it's going to be this kind of deal. Negative infinity to the left, positive infinity to the right. Remember those 4 categories I told you about? So this falls into that one. So negative infinity goes to positive infinity. That's wrong. Negative infinity, negative, positive infinity, positive. Yes, that's what we're looking for. For this one, that part's wrong. For this one, both of them are wrong. So that's just a leading term test. That's all I did there. Now notice only one of these first 4 problems have I actually done any algebra. The rest of them has just been a graphical analysis. Big part of this chapter is knowing what the graph of a function would look like and analyzing that graph. All right, part 5 here says, what is the greatest possible number of real zeros of the following? Once again, it's in standard form, and I see that the degree is 3, so that means it has a maximum of 3 real zeros. It definitely has 3 complex zeros. Some might be imaginary though. So the maximum number of real zeros is the same as the degree. So the highest power of x tells us how many possible real zeros a function might have. You gotta stop me if you're confused. Nice having everybody together. I think it's going to really help your grades too. I know it's been nice having a crazy light schedule for a year and a half, but it's about time we go back to work. Actually, it was almost exactly a year ago when things started to go weird.
It was right before we were about to take the ACT.
Yeah, so we started getting some news stories in February, which is about now. And people talking about it in China, being a big problem that's headed our way. And then in March is when we closed school. March.
If I remember right, it was a Friday that we got out, and we were going to take the ACT from the Monday that we came back, and then we ended up getting out for COVID.
Yeah, that was crazy times. Maximum number of turning points. Once again, we have n equals 3. And remember that the maximum number of turning points is n minus 1. So in this case, that's 2. So max 2 turning points. Let me just double check all my answers here. D, H, T. Yep, all right. 7, divide by using synthetic division. Cole, can you tell me what would go here?
-1.
Very good. And then Ben, can you tell me what this number would be?
8.
Very good. Peyton, what about this one? Hmm.
14.
You skipped one.
20.
Not just 20.
-20.
-20. There we go. And then that one, of course, would be -14. Brittany, what about this next one?
8.
Very good. Devin, what about the last one, homeboy? Awesome. Everybody see where all that comes from? Now be careful, because if this is not in standard form, now I'm not going to do that to you on a test, but you might encounter one on the ACT or sometime in the future where the terms are not in standard form. So double check that. Also, especially look out for missing terms where you got to use a 0. Okay, so 8, -28, +28. And so that would be, yeah, +14, -14, -6, 6, 7. So the answer is we go one less degree here. 8x cubed minus 28x squared plus 14x minus 6 plus 7 over x plus 1. You guys see whether that's the right answer? All right, synthetic division. Physics, number 8. Height h in feet of a ball thrown into the air t seconds is given, after t seconds is given by this formula. Use synthetic substitution to find the height after 0.5 seconds. So we want to know h of 0.5. Now we could plug this in the calculator or whatever, but that's not the task. The task is to use synthetic substitution. So I use 0.5 as my special number. And then my coefficients are -16, 25, 5.5. And then I want to find the remainder. We don't care about anything but that remainder, okay? Because that's where it's going to be our h of 0.5 by the remainder theorem. So -16 times 0.5 is -8. So 25 plus a -8 is 17. 17 times 0.5 is, we'll just go with the decimal here. 8.5, yeah. Because 17, half of 17 is 8 and then 1/2. So now if I add this, that's 1/14. So F as in Foxtrot is our answer. Only the remainder is what we concern ourselves with in this case. Let me know if you guys have a question. Number 9, that one seems easy, but it's also often missed. So 50% of the time, kids miss this one. Find the remainder when 16x to the 5th minus 32. Uh-oh. We got some missing boys in here. 32x to the 4th minus 81x plus 162 is divided by x minus 2. Is the binomial a factor? So we got a 2-part question here. What's the remainder? And is it a factor? Well, a couple of these I can discount right away. Why can I say this one is baloney right away? Well, because it's a non-zero remainder and they're saying it's a factor. That's not possible. And here, I know this one's baloney because zero remainder, and they're saying no. Zero remainder means yes. Non-zero remainder means no. So we can ignore those two without even computing the problem. That gets you to 50%. Okay, so let's see. I've got positive 2 as my special number, and then I've got 16, negative 32, and then x to the third and x squared are going to require a 0. 2 missing terms here. 2 missing powers of x. And then negative 81 and positive 162. So 16, 32, 0, 0, 0, 0, 0, 0, negative 81, negative 162, 0. So 0, yes. Questions about that one? Okay, cool. I bet if you left these out, you would get this number, don't you? That's probably a distractor answer. Gotta think like a test creator for your opponent. Sun Tzu said in The Art of War, every battle is won or lost before the army ever steps on the battlefield. In other words, it's preparation that allows you to win or lose. Very rarely is that not the case. Okay, so which is not a possible rational zero of, and then they give you a polynomial. So remember the rational zero theorem, the way that we can generate a list of places to check for zeros. So I see that my Q value, the denominator, is going to be an element of this set, because those are elements of that leading term. And then my numerator is quite a larger set here. 1 plus or minus 3 plus or minus 7 plus or minus 21. So I'm looking for something that has a numerator not in this list, or a denominator not in this list, or something that doesn't reduce to it. So this one is in there, 3 over 2. This one is in there, 7 over 1. 2 over 21. Oop, that's a problem. 21 over 2, that one's okay. You see how G couldn't be, because 2's not in this list, and 21's not in this list. So they're trying to see if you'll mix those up. G as in golf is the one that could not be a rational zero based on that analysis. Questions? Okay, cool. For a period of X days, an account balance can be modeled by, and they give us a formula. When was the balance $38? So here we're solving a polynomial. I want to know when f of x equals 38. In other words, when x cubed minus 2x squared minus 8x plus 3 equals 38. So get that equal to 0. If I subtract 38 from each side, it will accomplish that task, and here I am. So there's a couple things I could do. Rational zero theorem. Generate zeros. Test those with synthetic division. But, you know, why would we do that? Let's just use a calculator. The one, you know, like reasonable argument is when you take that statewide dual credit test, you won't have a graphing calculator. So you do have to know those other methods to solve this type of problem on that test. But we'll cross that bridge when we come to it, as they say. If I look at my table here, I see that at 5, I have a 0. Day 5. So also, you know, if I were to have generated that list, then this is how that would have worked. The by hand method. But I would have had to have tested everything up to that point. I suppose we could have confined ourselves to this list of answers. That would have been more efficient, but anyway. So that's problem 11. Problem 12, what is the horizontal asymptote? So remember that this is a case, and don't get hung up on the N's and M's, because for whatever weird reason, everybody's brain is quirky. I like to switch those around sometimes. So I teach it one way one time, and one way another time. So the degree of the numerator and the degree of the denominator are what we're concerned with. The degree of the numerator higher means there is no horizontal asymptote. The degrees the same means it has a horizontal asymptote at the ratio of the leading coefficients. And finally, if the degree of the denominator is higher, it has a horizontal asymptote at y equals 0. In this case, they're the same. So the ratio of the leading coefficients, that's 1 over 1, which is y equals 1. Because the degrees are equal. So we look at the ratio of the leading coefficients. 1 over 1 is 1. It's kind of an oddball problem here. The resistance R of a circuit is given by the following. So 1 over R equals 1 over R sub 1 plus 1 over R sub 2. Find the resistance if R sub 1 is 10 ohms and R sub 2 is 15 ohms. So 1 over R equals 1 over 10 plus 1 over 15. Need a common denominator here. So 30. 3 over 30 plus 2 over 30 equals 5 over 30.
6.
Yes, which is 6. We flip both sides. Six ohms is what we're looking for.
Why would we flip it?
Because it's 1 over R. And we want to solve for R.
I don't know.
Yeah, not its inverse. We want to solve for R itself. As I recall, this one also pretty frequently missed. You know, I could plug this in my calculator and this and see where they intersect also. That trick works for any equation. Any of them. No limit. 14. So which of the following could be the function represented by the graph? We've got a couple things going on. So I got an infinite discontinuity or a vertical asymptote here. Looks like an x equals -2. And I've got a hole over here at x equals +3. So I'm looking for a shared 0 at x minus 3 and a non-shared 0 at x plus 2. So shared at x minus 3. So we're looking for one that has x minus 3 in both the top and the bottom. Only here is that true. So H is in hotel has to be our answer. Meets the other criteria as well. But the first criteria is only met by that one. That's it. Questions? Graphical analysis. Order of the day for chapter 2. 15. Rational equation. This one will be a little tricky. Notice I've just breezed through these problems up to this point. One required a little bit of work, but this one might be the most intense yet. So what I need to do is get common denominators throughout. X plus 1, x minus 6. This just conveniently for us is x plus 1 times x minus 6. So I see that I need to multiply each here by the other's denominator in order to have that common denominator. So I take the leftmost term and I'm going to multiply the top and bottom by x minus 6. the rightmost term on the left side. Going to multiply that by x plus 1. And I needn't do anything to the right side of the equation because it's already over what will be that common denominator. Questions? Okay, cool. And I need to make a mental note going forward that x could never equal -1 or 6. So any solution set I get, I must exclude those values at the end if they pop up. Might or might not. So multiplying this out here, I get x squared minus 8x plus 16 over x squared minus 5x minus 6. X times x is x squared. X times minus 6 is minus 6x. X times minus 2 is minus 2x, which combine to make minus 8x. Minus 2 times minus 6, that should be a 12, actually. Boo-boo, sorry. Good thing I double-checked this. Plus, over here, a little trickier. So I got 2x squared. Two x times x is 2x squared. And then minus 7x and plus 2x, which make minus 5x. And then minus 7 over x squared minus 5x minus 6 equals x minus 3 over x squared minus 5x minus 6. Notice now, common denominators. I might now set all the numerators equal. Just ignore the denominators. But I have to remember that these can't ever be answers. So that's the last vestige of that denominator's existence. So once we get them all the same, we can cast them out and consider all the numerators equal. So here's what I need to solve. Let's combine some like terms. X squared and 2x squared are 3x squared. Minus 8x and minus 5x are minus 13x. And we can mark them out as we go here. Make sure we don't use something twice. 12 minus 7 is plus 5. Now I need to get one side equal to 0. So I'll add 3 and subtract x. So I have 3x squared minus 14x plus 8 equals 0. And it says, yeah. Looks like the quadratic formula might be a good choice here. So a equals 3, b equals -14, c equals 8, x equals -b plus or minus the square root of b squared minus 4ac over 2a. You could also use your calculator, of course. So we got 14 plus or minus the square root. 14 squared, I think that's 196. Let me check though, because I'm not absolutely certain. Yeah, I was right. So 4 times 3 is 12 times 8, I think that's 96. 4 times 3 times 8. Yeah, 96. Over 2 times 3. So we got 6 here. So this is 14 plus or minus the square root of 100 over 6, which is 14 plus or minus 10 over 6, which is 14 plus 10, 24 over 6. 14 minus 10, 4 over 6. 24 over 6 is 4. 4 over 6 reduces to 2/3. So 4 and then 2/3 is our answers. B is in Bravo. We have to remember, if we had gotten one of these, we would have had to have cast it out. Okay? So because these weren't in our list, it was no big deal. But if we had arrived at one of these as a solution, it would have been an invalid extraneous solution. be careful with that with regard to these problems. Okay, any questions about that, sir? Sure, man. Although if I were you, I'd wait and hit my jewel later. Nobody laughing but you, bro. Yeah, as a general rule, I don't like to put poison in my body. I suggest you do the same. Which of the following is the solution to this? And here we have a quadratic inequality. Wait a minute, that doesn't look like quadratic. Yeah, it is. Just multiply it out. They kind of gave you a little gift here because it's factored. You know, the zeros immediately. I know 2x plus 6 equals 0 and x minus 4 equals 0 are the zeros of this function. Subtract 6, divide by 2, x equals -3. Add 4, x equals 4. So we know how to populate our sign chart right away. And then as far as the function goes, when you put something into the calculator, you don't have to expand it. The calculator will do that for you. So it's perfectly legitimate to put something in factored form, like so. And we see positive, negative, positive, which is the behavior we might have predicted. And so where is this greater than 0? Well, that's going to be here and here. And the way we would describe that, this part is -infinity to -3, not including, because that's just greater than. It's not greater than or equal to. Union 4 to infinity. So that matches G, I believe, as in golf, yeah. Questions about anything? Okay, cool. 17. The end is 9. So we want to solve a rational equation here. So a couple things. First of all, I want to get this related to 0. So we'll do that first. And if I subtract 1/3, so 2 minus 1/3, well, that's 6/3 minus 1/3 is 5/3. So 2 is 6/3 minus 1/3 is 5/3. Now I need to get the denominators to be the same here. So I'm going to do that by multiplying x times x minus 4, both top and bottom over here. And then multiplying top and bottom by 3 over here so that we have a common denominator. This makes sense to everybody? Kind of a tricky step. I just multiplied each term by the other's denominator to force a match. Okay, so that's 18 over 3x minus 12 and plus 5x minus 20 over 3x minus 12. Now we can combine our numerators and denominators into one term here. So 18 plus a -20 would be -2. Now on our sign chart, we need to include the zeros of the top and the zeros of the bottom. So the 0 of the bottom in this case is just +4. The 0 of the top, add 2 to each side, divide by 5, is 2/5. So that's the 0 of the top, 4 is the 0 of the bottom. Let's see how it behaves around those zeros. We'll plug it in here. Remember also you can plug this in and the original function and see if the graph is the same to make sure all this work is correct. Good way to double check yourself. Oops, forgot my parentheses. I think that's right. So positive, negative, positive. And we don't have an or equal to relationship here. But if we did, remember that the zeros of the bottom, in this case the 4, must always be excluded. This is a commonly missed problem because people don't consider that. So zeros of the denominator are always excluded, regardless of the sign here. So positive, negative, positive. Where is it greater than 0? Here and here. So x is from negative infinity to 2/5, and then from 4 to infinity. That's D is in delta. Pretty weak distractor answers here. That can make you question yourself, can the one you pick is so very different than all the other options. All right, on to number 18. Find the polynomial function of least degree with real coefficients in standard form that have the following zeros. -4, positive 2i, negative 2i. We have imaginary solutions, but they're in conjugate pairs, so we need to consider any others. So what I'm going to do is make a little template here. So I want P of x, and they call it f of x, doesn't matter, to be x minus a -4, x minus 2i, and x minus a negative 2i. And so that is x plus 4, x minus 2i, x plus 2i. Remember that multiplication is associative and commutative. What that means is I can change terms around in order. I can put parentheses around whatever I like. So I'm going to choose to do these rightmost two factors, multiply them together first because they've got a certain pattern. Do you remember that a minus b times a plus b is a squared minus b squared? So that's the formula from algebra 2. So I'm going to use that shortcut to rewrite that term. So this is going to be x squared minus 2i squared. So 2i squared is a little tricky. So that's 2 squared I squared, or 4 times -1, or -4. So that's actually x squared minus a -4, which is x squared plus 4. So I've got x plus 4 times x squared plus 4. Now I can multiply these out. So x times x squared is x cubed, first times first. Outer times outer plus 4x. Inner times inner plus 4x squared. Last times last plus 16. First times first, outer times outer, inner times inner, last times last. And this is not in standard form, so let's rewrite it. X squared plus 4x squared, x cubed, sorry. X cubed plus 4x squared plus 4x plus 16. Looks like G is in golf. Let me double check myself. Yes, that's correct. Stop me if you have any questions. All right, cool. Put this on. Needs even more, doesn't it? 2 more. But you know, we usually get harder as we go here. So this one is real tricky. You remember my data regression section where we talked about how to make mathematical models. So this, notice everything here is to the 4th power. That's what's called a quartic regression. If your test has, you know, like x to the 3rd, then that's a cubic regression and so on. So whatever the highest power of x is, that's the type of regression you're going to use in this case. And here we have a quartic one. So let's use our calculator to find which one of these models is closest to what we need. So remember that with your calculator, first of all, you want to populate that data. So let's hit stat and then edit. And I want to edit and I want to clear out what I've already got in there. So go up to the list's name, hit clear, and then down arrow. Don't hit delete. You'll have to reset your calculator. You delete that list, then you screw up all the defaults, and you have to just go through the reset function. In case that ever happens to you, hit second and memory, and then it's option 5 if you have to do that. All right, stat, edit, and we're going to put the x's in first here. So that's -5, -4. Uh-oh. -3, -2, -1, and then 0, 1, 2, 3, 4, 5. And then the y values 4, 0, 0, 0, 0, 1, 1, 0, 0, 1, 4. So we've got the data in there. Now what we're going to do, go to stat again, calculate, navigate down to quart reg, because that's a quartic function, remember, 4th power. So 0.015, so the 0.02 is going to be closest, which means I can disconsider the 0.2s. Because we see here, this is 0.02 for our A coefficient. Would not make sense for that to be a better model. And then B is real close to 0. Notice they don't even have it here, because if you go to the nearest 10th, it's 0. So that's why the cubic term is not present. And then positive or negative 0.25 for the squared term. So I think that's strong enough evidence for us to choose A as the closest to the calculator's model. Yes, that's correct. All right, last one, 20. According to Descartes' rule of signs, how many positive real zeros could this bad boy have? Well, looking for the number of sign changes. So here's one, because it goes from positive to negative. Negative to negative, not a sign change. Negative to positive, yes. Positive to negative, yes. So it has 1, 2, 3 sign changes, meaning it could have 3 or less by an even number, 1. So answer to that last one there is G as in golf. All right, ladies and gentlemen, you've got all the skills you need to take that Chapter 2 test. It's open and available on Google Classroom. Feel free to get started on it. You've got about 30 minutes. If you would rather continue to review the study material, you can do that. Test is due Sunday night, I believe, if I'm not mistaken. Guys, double check me on that.